in today's video we're looking at solutions and the concentration of those solutions. What we're talking about, if you remember, when I set out chemicals for you, sometimes I'll have a chemical that's labeled 5.0 molar. And that's the concentration, and let's say that's HCl. That's the concentration, how much HCl is dissolved in water. And we're going to learn today what that molarity is. But that's called a concentration. You can think of it as simply if you were making Kool-Aid, how much sugar do you have it in? How much sugar is in the solution? So if I add a lot of sugar and it's really sweet, that would be a high concentration. And so its molarity would be high as well. And so we're going to look at that. And we're going to look at the percentage of particles per given amount of solution. So again, if we're using the Kool-Aid example, how much sugar is in the sugar water? Molarity, we're going to be looking at how many moles of sugar is in the water. And dilution is how much water do we need to add to dilute the starting solution. So all of them are about solutions and changing the concentration or determining the concentration of the solution. Whenever one of your problems asks you what is the concentration, they are looking for molarity. If they're asking for a percentage of the mass, we're doing mass percentage. And if they're asking you to determine a volume, you're adjusting it, it's going to be dilution. I wanted to review something from your long-term packet last week that a lot of you had the wrong answers for. And here is a solubility curve. And it's called a curve because most of the lines do curve. Not all of them, but most of them do. And so when you have this curve, and I'm kind of highlighting this line here, that's the point of saturation. If you're right on this line, this solution can hold no more of that chemical. Below this line, we know it's unsaturated. So if I'm adding sugar to my water to make Kool-Aid, I'm adding sugar, unsaturated. Adding sugar, still unsaturated. Adding sugar, still unsaturated. But once I hit this line, I'm at saturation. Once you're at saturation, whatever I add, I keep adding more sugar, the sugar just goes to the bottom of the beaker or your pitcher or your glass, whatever you're using to make your Kool-Aid. And so it's not super saturated just because I added up to this point. It's actually, this is how much the water can hold of the sugar, and this is how much is going to fall to the bottom of your beaker or glass. Supersaturation involves tricking the solution, and unfortunately we're not going to be able to do that in this situation, but it's not a common thing with chemicals. So what we deal with in the chemistry lab is saturated and unsaturated. And so this week's topic on Google Classroom, I have it as April 6 through 9. Notice that we're not in school on Friday, so your exit ticket will be due on Thursday from noon to 4. For this video I'm making, the worksheet is on Google Classroom. And it would help you to stop the video now and print out that worksheet if you haven't already. If you don't have a printer, what you could do is just write down the problems as we're going along, or maybe have, I'm not quite sure how you would do it otherwise. So I'm going to do all the work for the problems on the whiteboard, and you follow along in your notes. Notice on the syllabus, there's a lot of key terms there that you should recognize. Half of them we've had in the past, such as aqueous solution, something that's dissolved in water. The likes, dissolved likes is going to come up again. So I would like you to watch this video. You could stop it. There's 3 different parts here. These are the 3 different parts. And practice these problems before you try the OWL problems. And if you do all of these problems, you do the OWL problems, you're ready for the exit ticket on Thursday. Now, another new thing we're going to be trying this week is between 1 and 2 and 3 and 4, I'm going to have the code to the Google Meet, and I'd be glad to answer any of your questions. So if you're stuck on a problem on OWL, that would be the time to ask me, and I'll set it up that I can do the work in front of you. Make sure you have that problem like written down somewhere, because I have not figured out how to do this yet, that I can see your problem as I'm doing the work. Normally I would have my computer and the whiteboard to work on. So we'll make sure you know the number of the problem that you want me to address, and whether it's activities or mastery. All right, let's get started here. We're going to start with mass percentage. So flip out here. And so this is the formula you want to have written down for mass percentage. It's mass percentage equals the mass of the solute, that's the material I'm putting into typically water, over the mass of the solution. The key here is this is a solution, so it includes the solute and the solvent. So on problem number 1, I have 135 grams of seawater. And 135 grams seawater. And we evaporate that. And when you evaporate it, the water's gone. And we're left with 4.73 grams of a solid. That solid would be anything that's in seawater, which we think sodium chloride or magnesium chloride. And then it asks us, calculate the mass percent of the solute present in the original seawater. So here's our formula. And I'm going to switch out my pen to have a little different color here. So I'm looking at this. Seawater is a combination, it's a solution that combines the solids, the minerals, plus the water. So my solid here, or minerals, would be my solute. The water would be my solvent. And my solution is the seawater. So to do this, and I did forget to put on here my formula, should say times 100. You guys know that from math class whenever you do a percentage problem. So I have my mass of solute would be 4.73 grams divided by 135 grams times 100. So I'm going to put that in the calculator, and I get 3.50%. That's my mass percentage for this problem. So we're going to look at the second problem here, and I'm going to keep the same formula. And now I have 2.50 grams of calcium chloride. and 52.5 grams of water. I'm sorry, I messed that up. They gave us 50 grams of water. All right, so 2.50 grams of calcium chloride and 50.0 grams of water. So we're going to mix these two things together and we're going to have an aqueous solution. So here's my formula. They want to know how much calcium chloride, what percentage of this is going to be calcium chloride. So I'm going to use the same formula. Mass of solute would be 2.50 grams calcium chloride divided by, now here's that trick here, it's a solution. Water is your solvent. Calcium chloride is your solute. The combination is your solution. So I'm going to have to add these two numbers up to get the solution, which would be 52.5 grams of water. We're going to multiply that by 100. Now, when I say water, I really should have said calcium chloride aqueous, right? Because I combined these two together. Now, when I multiply or divide this and multiply by 100, I'm getting 4.76% calcium chloride. 4.76% calcium chloride. Again, the trick to this problem was I needed to add up both of these numbers to make a solution. All right, now let's look at the next problem. I'm going to have you do more on your own. The next problem says we have 75.0 grams sample of a solution. By mixing 2.50 grams, by mixing, this solution contains 23.8 grams of glucose. I don't know if you remember from biology class, glucose is C6H12O6. Calculate the mass percent of glucose in this solution. So it's giving us that the solution is a total of 75.0 grams and that I'm putting in glucose 23.8 grams. So what is the mass percent? Go ahead and set up your problem. I'm going to pause your video. And we should have, I'm going to put my solute is the glucose, 23.8 grams, divided by my solution, 75.0 grams, times 100. And when I divide and then multiply this, I get 31.7% glucose. So my solute was the 23.8 grams of sugar. The water was my solvent. I'm kind of guessing it's water because they don't tell me. And the solution I put as sugar water. All right, number 4 is going to get a little trickier. All right, number 4 says vinegar is a solution of acetic acid and in water, and typically contains 5% acetic acid by mass. So 5% acetic acid makes up vinegar. Calculate the mass of acetic acid in a 250 gram sample of vinegar. And do we have any decimals? Yeah, so there's 4 sig figs there. Vinegar. Now, if I didn't ask you for this, but if you asked for the solute, what would be the solute here? Would be the acetic acid. The solvent would be the water, and the solution is vinegar. So when you're buying vinegar, you're buying acetic acid dissolved in water. And so now to solve this problem, we're no longer looking for the mass percent, we're looking for the mass of the solute. So we're looking as this is my unknown. So now I need to take that mass percentage equals mass of solute over the solution. And again, both of them are in grams. And so when I'm filling this out, I now know my mass percentage already. Now, you know in math class, you can't have the percent sign there to do math calculations. So I have to switch this, move my decimal over 2 places. 100 percentage is based on 100. So that has 2 zeros. I move my decimal to the left 2 places, making this 0.05. Okay, changing my percentage. And then I don't know X grams, but I do know my solution is 250.0 grams. So in a math class, and we've done a little bit of this year, this is kind of understood as over 1. And to solve for my X, because they equal each other, I would multiply 0.05 times, there's no units on this, 250.0 grams. And from that, I'm going to get 12.5 grams of acetic acid. And you guys know acetic acid as this, because there's acetate, and we got an ick, so acetate plus the hydrogen, because this is a negative one, so that's my formula. So 12.5 grams of acetic acid. We're going to do one more problem like that, number 5. I want you to go ahead and set that up. We have 37.2% mass of HCl. And it asks, what is the mass of the hydrochloric acid if we have 35.5 grams of a concentrated HCl? Now, when you do your reading, you're going to learn that this is dissolved in water, but not a lot of water, very concentrated HCl. So this is my solution. Again, we're always going back to these words here. And so now I want you again, take a moment to set up this problem. Now again, I got to convert my percentage, 0.372. I'm going to take this as an understood 1, cross multiply. When I cross multiply 0.372 times 35.5, I get 13.2 grams of hydrochloric acid. All right, that concludes the first part of this video, all on mass percent problems. You can continue to work on this worksheet, or you could go to the OWL problems and look for mass percentage problems you want to practice there. I'm going to go right now into molarity. And molarity is a concentration. But instead of looking at grams, we're looking at moles. Do I have this set up right for you? All right, so molarity is a concentration, and we're looking for moles and liters. Now, I'll tell you, on the next two, they almost always give us grams, and we're going to have to convert to moles. That's why I had you practice last week on those conversions. So, problem number 1. It says calculate the molarity of a solution prepared by dissolving 1.00 grams of ethanol, C2H5OH, in enough water to give a final volume 101 milliliters. Notice another thing they'll do in the problems, especially on OWL, they'll give you milliliters, but you need to have it in liters. Your volume is in liters. So we're going to switch that right away to 0.101 liters. And they gave us grams. We can't use grams. We need moles. So we're going to do 1.00 grams. Convert that to moles. This is going to be with us the rest of the year. Grams and moles, I know how to convert. So I'm going to get rid of grams here. So I'm getting rid of grams. I'm going to moles. And if you remember, we're just going back to using that 1 mole equals Avogadro's number equals the molar mass. These three things are equal to each other. So for every 1 mole, we get the molar mass here. So we have to add up the molar mass. 12 plus 12 plus 5 plus 16 plus 1 gives us 46 grams. And then I'm going to divide 1 by 46 because I'm multiplying across, dividing by the bottom, and I get 0.02174 moles. I'm going to take that mole and I'm going to go back to molarity. Molarity is a capital M. It's very important that you use a capital M. There's going to be molality later, and it's a little m. So molarity, I need to put the moles on top, and this is my moles, 0.0217 moles. A lot of students will ask me, why am I using so many numbers? I usually do 4 sig figs when I'm doing the moles, because this is not going to affect my sig figs. My sig figs always come from the numbers in the original problem. So we know we're going to have 3 here, 3 here. Our answer is going to have 3. You don't want to shorten that so much. If it was 0.02, it's going to give us a different answer. So I usually go out to 4. And then liters are on the bottom. We got our liters here, 0.101 liters. We divide that out. Our molarity equals 0.215 molar, or moles per liter. We could say that either way, moles, molarity, or moles per liter. All right. So let's try one on your own. You're now on the second page, number 7. I want you to set that up on your own. We'll pause the video here. And in this problem, they're giving us 2.80 grams of sodium chloride and using enough water to make 135 milliliters of solution, salt water. So again, I'm looking for, they're asking me for molarity. I need moles and liters, but they gave me grams and milliliters. So most every single problem you do, whether it's on OWL, this worksheet, or on the exit ticket, you're going to be converting. So the first thing we need to do is convert our grams to moles. 2.80 grams sodium chloride times our fraction. I'm going from grams to moles. And I know that for every 1 mole, I have the molar mass here, and that's 58.5 grams, adding up 23 plus 35.5. Now, if your answer is slightly off, like 0.1, 0.2, you're not doing anything wrong. So I'm going to multiply across, divide by the bottom, and I get 0.04786 moles. Again, I'm just going out to 4 sig figs. Now, I'm going to do my molarity, and I know moles goes on top, 0.04786 moles, divided by, now I need liters. Again, they gave me milliliters, so I'm going to take my decimal 1, 2, 3 places to the left, 0.135 liters. We're going to divide that out, and we get 0.355 molarity, or